Okay, so welcome to the Unit 2 test review. We're going to be going through each one of these problems step by step here, so feel free to skip through if there's certain problems you're looking for and how to do. You can just skim through the video and get to the other questions that you need help with. So we're going to start with number 1. So right away, first of all, this is outcome 0. Outcome 0 returns again. This is more stuff that you should know how to do from Algebra 1. This is basic factoring. Not solving, just factoring. Solving is what we did, and that is outcome 7. But factoring, just factoring itself, is going to be outcome 0. And so really all you have to do here is just do the first few steps without solving. So again, just like in class, when we were doing these first few steps here, the first step is going to be to look for GCFs. And with this particular one, you will see that you have a y that is common in all of the terms. But then also that all of them can be divided by 6. So, excuse me. So I can divide all of these by 6. And so that 6 that I'm dividing out and that y that is common throughout each term is going to come out just like this. Now, when I go in parentheses to put what's left over, I am going to divide all the numbers by 6 and then take a y away from each term. So 6 divided by 6 obviously is just 1, so it's just x squared plus 48 divided by 6 is 8. So you have 8, and then there's an x there because the y is gone. And then 120 divided by 6, a negative 120 divided by 6 is negative 20. And then the y is gone. So that is it. Now you might think you're done taking out GCF, but no, you're not done because factoring isn't just GCF. We have to do, this is, again, factoring, so we can use our AC method. AC method does A times C. In this case, our A is 1, so 1 times negative 20 is negative 20. And our B right here is 8. So just like we've done in other problems before, you're trying to find two numbers that when multiplied are negative 20 and add to be 8. If you'd like to pause the video and try to do this on your own, you can, but I'm just going to go ahead and give you the answers. The answers are 10 and negative 2. 10 times negative 2 is negative 20, and 10 plus a negative 2 is 8. And so we go then to our dead cartoon eyes, and with our x's in there, and then you just drop down those factors of x plus 10 and x minus 2. That 6y that you brought out at the beginning will just come out in front here, 6y, and that is your answer. That is factoring. If I'd asked you to solve, you would then set each of those equal to 0, but since we're factoring, that is it. Number 2, I have a feeling there's going to be a few questions about this one. There's a couple ways you could go about doing it. In the notes, when I went over the notes, this is what is called a difference of squares. So if you have your notes on a difference of squares and you want to try to do it that way, you can. Otherwise, you don't have to do it like that. You can do it the A times C method. Now, what you should notice here is I have x squared, and then but I don't have my x. I don't have my c. I have my a because the a is with the x squared, but b, which is normally with the x, is gone, and I do have my c, or my constant. So I'm missing b. So when you do your a times your c, 16, you're doing 16 times negative 25. So let me just get the calculator out because I don't know that off the top of my head. 16 times 25. So negative 150. And then my b, which is non-existent, would just be 0. So the goal here is to find two things that multiply to be negative 150 and add to be 0. The trick here, because it adds to be 0, obviously it's going to have to be the same number. And I think I did that wrong. 16 times 25 is not 150, it's 400. Some of you are probably like, Mr. Goulet, what the heck? I just put 6 times 25, not 16 times 25. That's negative 400. So because they add to be 0, the numbers are going to have to be the same. Obviously, if two numbers are going to add to be 0, it'd have to be positive one number and then negative the same number. That's the only way. So the two numbers have to be the same. So what two numbers would multiply to be 400 have to actually be the same number. If you want to pause and you want to try and do this on your own, you can. Otherwise, I'm just going to go ahead and give you the answer. The answer is 20 and negative 20. 20 times negative 20 is negative 400, and 20 plus a negative 20 is 0. So now, when we go to do our dead cartoon eyes, we drop down those factors. And then we have to be careful here. Our A is not 1, it's 16. So we do have to divide both of these by 16. And then those fractions, I'm going to go ahead and reduce these fractions. You don't have to. 16 obviously doesn't go into 20. So if you want to write it, I'll just write this over the side. If you want to do, when these slide over here. So it would be 16x plus 20 and then 16x minus 20. You can certainly do that. I'm going to reduce this fraction. This ends up being 5 over 4. So I end up getting x plus 5 over 4, x minus 5 over 4. And then I'm going to move this over. So then I get 4x plus 5 and 4x minus 5. I wanted to do it that way. You're like, why are you doing it that way? You said we don't have to do it that way. I want to do it that way because those of you who, remember I told you there's 2 ways to solve this problem. In your notes, I also showed you how to do difference of squares, and this is a difference of squares. And if you did do it using a difference of squares, then this is the answer that you're going to get. If you did it just the traditional factoring way with your b being 0, then you're certainly able to leave it like that if you want to. Either answer is fine. Number 3 is grouping. The reason why it's grouping, now we haven't done much grouping in this class because we don't really get into grouping that heavy until we get to polynomials, but this is a skill that will absolutely be necessary later on this semester. So we need to be able to group. So this is in the notes. If you want to go back and do the notes, or you want to go back and look at the notes, you can. Remember, you can use your notes on the test or any quiz. But basically, what tells you that this is grouping is, there's a bell. What tells you that this is grouping is the fact that there are 4 terms. The fact that there are 4 terms is that signifies us the red flag, like, hey, I'm grouping. And so what you do is you're going to group the first 2 terms and then group the second 2 terms. And then you are going to take out a GCF in each one. So if we divide out, we try to do a common GCF in each one. So it looks like there is a B in each one. There's also an A common in each one. So it looks like I'm going to be taking out A and a B. So the A and the B will come out. Now, because there is an A squared, there technically is 2 A's there. So by taking out an A, there's still an A left over. Now the B is gone, and then there's a minus 2, and then that A and B are gone there, so that's all that's left. In the second one, you would take out a GCF again. In this case, the C is your GCF, and both of them can be divided by 6. Now, there's a trick here, something that we have to recognize. If your first number in your terms, when you're doing a GCF, if your first number is negative, then the number that comes out has to be negative. Now, since a 6 goes into both of those, I will have to take out a negative 6, and the C will come out. So, and then negative 6 divided by negative 6 is just 1, so it's just A. 12 divided by negative 6 is negative 2. That C is gone, So that is it. And we're almost done here. The final step in grouping is to then bring the GCFs together in the same parenthesis, like so. And then the two common ones will come together in the same one. So A minus 2. And that is factoring by grouping. Okay. All right, that is for outcome 0. That's all we're going to do. You're not going to have anything like this. I'm not going to make you do anything like that. So you can go ahead and cross that out. You don't have to do that. You won't see it on your test as well. Now, outcome 6, we already did these problems. We did these together in class. So I'm going to go through this very briefly when you're going through this in class. Basically, what you need to do here is to use the graphing calculator to find these answers. All right. So I don't know how to bring in. Let me see if I can split screen here with the calculator here. I'm going to go to Canvas. And then algebra here, and then pages. Let's go there, and then calculator link. Probably should already have this ready to go, but it's okay. Put that over there. So now I'm going to bring up Notability. There we go. So I don't think it's going to let me. Nope, won't let me do that. Okay, so we're just going to have to deal with it halfway. So here, basically, all it does is says to find the roots. It doesn't ask me to find vertex or y-intercept or anything like that. It just says to find the roots right here. This simply just means to find the x-intercepts. So what you're going to do is go into the y equals on the graphing calculator and go and you're going to put this in. So x squared minus 4x plus 15. And I'm going to go and put that in the calculator, and I'm going to go ahead and graph it. Now, the first thing I'm going to notice, obviously, if I'm using this on a brand new calculator, if I'm using the online one, is I don't see it. That means that it's not that I didn't graph it right. It's that the graph itself is actually outside the window at which I'm looking at. So I do need to zoom out. So I'm going to zoom and then go down to zoom out, hit enter. I will need to hit enter again once I get to the screen to actually zoom it out. And there we see it. It is up and outside of the window. So what I should notice here, first of all, the first thing I need to do is draw a sketch of this. It doesn't need to be perfectly accurate, just something close. But then when it tells me to find the roots, it's asking to find the x-intercepts. So one thing you should notice right away is this doesn't have any. There are none. It does not cross the x-axis, therefore there are no x-intercepts. Now that's going to be different from this one. First of all, if you remember from class, we can't do it. We can't put this in the calculator like this. We do need them all on the same side of the equal sign, so I'm going to move those over. So I get x squared and then plus 13x plus 20 equals 0. We need them all on the same side whenever we're working with the calculator or factoring or quadratic formula. Pretty much almost every time we're going to need it on the same side. So now I'm going to go ahead and put this one in. So I have x squared, and I'm going to do plus 13x and then plus 20. When I go ahead and graph this one, you definitely have some x-intercepts here, so I'm going to go ahead and sketch the graph here. It goes something like this. Again, it doesn't need to be perfect, just needs to be done at least remotely accurate. Now to find the x-intercepts. Now that we know we have them, we do need to find the x-intercepts. They're right here and they're right here. So I'm going to go, if you remember, you go to second and trace, and then we go to 0. 0 is where we find the x-intercepts. Remember that you need to place your cursor near your x-intercept. Doesn't matter where, just somewhere in the vicinity of your x-intercept. And then it says left boundary. Okay, so that reminds you that you do need to always go left first. So I'm going to go left and then hit enter. Then I'm going to go right, hit enter. making sure that the cursor does cross the x-axis. It did cross the x-axis, so I'm good. And then hit enter a third time, and it tells me my x-intercept there is negative 11.2. So I'm going to put negative 11.2. Sorry for all the bells. It's the beginning of block 1. Well, normally block 1. Now to find the other one, second and trace and 0 again. And now we're going to bring the cursor on the, whoa, too far, on the other side. I'm going to put the cursor near the x-intercept as close as I can to it. And then it says left boundary. So I need to remind myself I need to go left a few times, hit enter, right a few times, making sure that it does cross the x-axis, enter, and enter again. And you'll see that the other x-intercept is negative 1.78. Whatever, or 1.8, negative 1.8. However you want to round, it's fine. And that's how we find the x-intercepts. And that is all you need to do for outcome 6. No vertex, no y-intercept, just roots, or just x-intercepts. Now on to outcome 7. This is our second to last one here. This is probably where you're going to spend most of your time. I don't need a graphing calculator anymore. Whoa, huge. Okay. Now on to what we should see here are 8 and 9. 8 and 9, just to want to point out here, there's a difference between 8 and 9. Notice how in number 9 you have 2 x's, but in number 8 you only have 1. It's like that for a reason, because number 8, since there is only one set of x's, or one x here, I'm going to solve this differently than I would solve this one. There's really only 2 ways you need to know how to solve any of the problems in outcome 7, and that is quadratic formula and solving by square roots. This would be solved using the quadratic formula. This would be solved by square roots, and that's because of the single x. The reason why we do it that way is because when there's only one x like this, I can actually solve for it. So if I just isolate the x the same way we solved every other equation when you were doing this in algebra, it makes it really easy. So I would just bring everything over. The minus 15 would just add 15 to move to the other side. And then I'm left with 9x squared equals 576. We did do this the other day in class, I know. So I'm going to move through this quickly. You want to make sure, be careful. A common mistake here, kids want to take the square root prematurely. You cannot take the square root until there is nothing else to do. Okay, so I cannot take the square root right here because I can still divide by 9. If there's something you can do, you want to do that before you take the square root. You save the square root for last. That gives me x squared equals 64. And then when I take the square root of both sides to get rid of the square, I do get 8. Don't forget that it is plus or minus. Anytime you're working with square roots, you always need to remember the plus or minus. Plus or minus. Always plus or minus. Okay, that one should be pretty simple on the test. When we get to number 9 here, because there are multiple x's, I cannot use the same method to solve that one. I'm going to solve this using quadratic formula. Most kids will not go to factoring just because factoring doesn't always work, whereas the quadratic formula will always work. And so I always tell kids, just use a quadratic formula. It works every time, and you don't have to worry about whether it's going to work or not. So the quadratic formula, you will be given this, or you will be able to use your notes, so there shouldn't be any issues here, but it is opposite of b plus or minus the square root of b squared minus 4ac all over 2 times a. So I'm going to fill everything in here. X equals, okay, opposite of b, so I'm going to do opposite of b, which is positive 4, plus or minus the square root of b squared. I told you guys in class to not actually write your b in squared like that. Don't do that, okay? Do it in your head. There's less room for mistakes there if you actually do it in your head, trust me. Negative 4 squared is negative 4 times negative 4, which is 16, minus 4 times a, which is 1 in this case, and times c, which is 4. All over 2 times a, or 2 times 1, which is 2. Now I'm going to do this problem right here. X equals 4 plus or minus, the first thing you're going to want to do is do the discriminant. The discriminant is what is inside the radical. That is going to tell you what type of solutions you're going to get. So I could do 16 minus 4 times 1 times 4 all in my calculator. I can do all of that all at the same time. 16 minus 4 times 1 times 4 all in the calculator gives me the square root of 0. That should tell you something. If you remember from learning about the discriminant, if you get a 0 in there, that means you're only going to get one solution. So let's see if we only get one solution. Okay. Now, the square root of 0, hopefully you know this, is 0. So it's just 4 plus or minus 0 over 2. And so I can actually break this down now into 4 plus 0 divided by 2 and 4 minus 0 divided by 2. 4 plus 0 is 4 divided by 2 is 2. 4 minus 0 is also 4, and divided by 2 is 2. And lo and behold, we do get only one solution, and that solution is 2. Because the discriminant was a 0, that tells us we're going to get one real solution. We'll play around with more of the discriminant a little bit later, because that is outcome 8. Let's go down here. We also did number 10 in class the other day, so I'll breeze through this a little bit quicker here. Again, we're trying to isolate the x. Hey, remember what I told you. Imagine that x has Ebola, or x says, I have a bomb. Okay, the goal here is to prevent you from trying to distribute. If you think that x has a bomb, then the 2 is not going to go in there, and this 2 is not going to go in there too. The reason for that is because that is not mathematically allowed. You cannot do that. So don't do that. Do not distribute the 2. Do not distribute the exponent. Do not put anything in these parentheses. Nothing goes in these parentheses when you're doing that. Please do not do that. I say that knowing that there will be people that will do that. Do not do that. You cannot do that. X is a bomb. No one's going checking out, hey, who's got a bomb there. So I told you guys in the story here that if X said he has a bomb, here's the door. We need to get everything outside. The first one that's going to go is the 11. So we add the 11 to the other side. 11 is out of the door safely. We now have 2, and then x plus 17 squared equals 126. Now, the 17, we got a problem with the 17, or actually the 17 has a problem. He's trapped. The x there that has a bomb, he went over and is holding on to 17 here, and it's bounded by these parentheses. You cannot remove anything from these parentheses. 17 is stuck. So actually the next person to go is going to be the 2. So to get the 2 over the other side or out the door, we're going to divide by 2. Now that gives us x plus 17 squared equals 63. Now that we're at the very end, we're going to send in rescue. We got to rescue 17, and the only way to rescue him from this square and parenthesis is now to do the square root. By doing the square root, it will cancel out the square in the parentheses, setting the x plus 17 free. Now, square root of 63 is not a nice number. It's not square root of 64, awesome, that's 8. But square root of 63 is some crazy decimal, 7.9 whatever. So we just leave it as square root of 63. Do not try to put that as a decimal. We don't, remember what I told you about radicals? Radicals are either perfect, and you can give them as perfect numbers, or they're just left as radicals. They are never, ever decimals. You will never, ever put a square root into your calculator unless it is a perfect square. You should never get decimals. We do have to remember that it is plus or minus, though, but we're going to leave it as square root of 63. Now the 17 can finally come over. You can get out the door. There's the door. So we have x equals plus or minus the square root of 63. Because 17 and square root of 63 are two different numbers, one's a square root, one's not. They're not like terms, and they cannot combine. So they just get attached onto the end there. And that is it. Moving on to number 11. Number 11 is a little odd at first because it's not equal to 0. I do have to bring the 4x over and put it in its place. Remember, it should go a is with your x squared. B is with your X, and C is the number that's by itself. Since your B is the one that is actually needing to move, you need to make sure that the 4X does go in its rightful place in between A and B, or A and C, sorry. Don't put it on the end. It needs to go A, B, C, not A, C, B. So the B is actually on the other side. We're going to bring it over. So I have 3x squared. Moving the 4x to the other side will cause it to change signs to minus 4x and then plus 2. Now that we have everything on the correct side of the equal sign, now we can do our quadratic formula. So there's A, B, and C. So I'm going to use quadratic formula again. Let me just change different colors here. I'm not going to write the quadratic formula again. You have it. I already wrote it down. But it is the opposite of B, which is now positive 4 plus or minus the square root of B squared. Negative 4 squared, negative 4 times negative 4 is 16. Minus 4 times A in this case is 3. C in this case is 2. All over 2 times A, or 2 times 3, which is 6. Now, again, first order of business is to do the discriminant. 16 minus 4 times 3 times 2. You can do that all on your calculator. You can put it straight in as it is. 16 minus 4 times 3 times 2. That is going to be negative 8, I think. Negative 8. So I get 4 plus or minus the square root of negative 8 over 6. Now, having a negative in the radical tells me that I'm going to have imaginary solutions, 2 imaginary solutions. That's what the discriminant tells you. Remember what I mentioned here with a negative inside the radical. We can't have a negative inside the radical, so those scientists long ago fixed it by simply placing an I in front of the radical. That negative goes away. And you are done. So all you need to do at that point is that. So not anything crazy. Imaginary numbers are not anything crazy. Finally, the last one here, alchemate. These are just the discriminant. This is by far the easiest outcome on the test and probably one of the easiest outcomes we have in this entire semester. Basically, all you need to do is find the discriminant. Remember, the discriminant is just the b squared minus 4ac. So it's the same a, same b, same c. All I need to do is find that number. Remember, if the number is positive, that means I have 2 solutions, 2 real solutions. If the number is 0, then I will only have 1 real solution. And if the number is negative, as you saw in the previous problem, I will have 2 imaginary solutions. So let's find out what this is. B squared, negative 4. Again, don't write negative 4 squared. Do negative 4 times negative 4 in your head. Negative 4 times negative 4 is 16 minus 4 times a is 1 and c is negative 12. Again, put the whole thing in your calculator. If you're graphing calculator, 16 minus 4 times 1 times negative 12. What is that number? Now you should get, let's see, 50, is that 64? I think. 4 times 12, 48, plus 48, 58, 60, yeah, it should be 64. 64 is my answer. It doesn't really matter what it is. It is positive. So this means that I'm going to have 2 real solutions. If it were 0, I'd have 1 real solution. And if it's negative, I have 2 imaginary solutions. Let's see what this one is. Okay, again, b squared minus 4ac. I'm going to do b squared, negative 4 squareds. That's a lot of negative 4 squareds. Negative 4 times negative 4 is 16 minus 4 times a, which is 1, times c, which is 9. We're going to go ahead and do that. 16 minus 4 times 1 times 9 is negative 20, I believe. Negative 20 is my discriminant because it does say to determine, use the discriminant to determine the number and type of solutions, which means I'm going to have 2 imaginary solutions because it's negative. And that is your review. I do want to point out, though, that you will have outcome 1 and 2 on this test as well. please refer back to the Unit 1 test review to review what is in Outcome 1 and Outcome 2 on transformations. Remember, it's the same transformations, absolute value or whatever, only this time it's going to be with parabolas, but the same rules apply. So don't forget, there is Outcome 1 and 2 on this test as well. Hopefully this was helpful. And this is your answer key as well. If you need to refer back to here, you can check all the answers. Good. Have a good day.